Hello and welcome to the section 2.6 notes today. We're going to take a look at dividing whole numbers as kind of a segue. Ultimately, we're going to get into dividing decimals, but we need to understand how to divide whole numbers in order to be able to divide decimals. So most of what we're looking at today is not a simple like single digit division. We are looking at some more complex problems. Uh, as we get going here. So let's go ahead and get started. The first thing that I have is kind of a just kind of layout of all the different forms of how we see division, and that's in this first box here. The quotient's always going to be the answer. The first one that we see here is kind of the fraction form of a division problem. Still a division problem. The number on top we call the dividend. The number on the bottom we call the divisor. The next one is like a single line division problem. And that would always be the dividend is first, the divisor is second. When we work these problems out, a lot of times we're going to use long division. In the long division kind of algorithm or sequence of steps that we follow, the dividend is underneath the kind of whatever you want to call this symbol. I know there's a fancy name for it, but it's okay. The divisor is always the number that's outside of that. The one thing that I do want you to add here is that a lot of times we'll see division problems that don't work out evenly. In other words, they have a remainder. The old school answer with remainder was like something like quotient, remainder, whatever. We just say R and then number. We want to up that game a little bit. So we're going to put the remainder over the divisor as part of our answer. So it'll be the quotient and then the remainder over the divisor, a mixed number for that answer. There are typically 5 steps to division, to long division. We divide, multiply, subtract, bring down, and repeat. I'm going to look at kind of a different way to get that done. It helps out more people that have that kind of struggle with that idea of long division. And so to get that done, we're going to go ahead and take a look at our first example here. I'm going to start with a list of my divisors. Sorry, a list of multiples of my divisor. I'm going to go to about 9 multiples. 9 will be the biggest number of multiples that I'll need. And so that's 6 times 8. We need 7, 8, and 9. So I'm going to show you how that list can be helpful. Now, another thing you could do is to say, like, this one's the first multiple of 8. This one's the second. Okay. That could help. I find myself more often than not doing that. But you could do that if you wanted to. You needed a little extra help. So what I'm looking for is I'm going to start with my first number, 6. Are there any numbers in my list of multiples that are smaller or equal to 6? And no, there's not. The smallest number I have is 8. So then I'm going to bump over to 67. Are there any numbers on my list that are smaller or equal to 67? And there's a bunch of numbers that are smaller. I always want the biggest one. Okay, the biggest one in this example is 64. 64 is the 8th multiple of 8. So I did need that information at some point. And then I subtract. 67 minus 64 is 3. Bring down the 2. And now I repeat. I need a number on my list that's smaller or equal to 32. I have 32 right here. That's the 4th multiple of 8. And when I subtract, I get 0. There's no remainder in the problem 672 divided by 8, that's always going to equal 84. Okay. On my next one here, I'm going to kind of start the same way. I'm going to start with a list of my multiples of my divisor. And I need to get to 9 multiples. So another idea that I'm doing is just adding 9 every time to get that list. And then I'm going to start the same way. Is there a number on my list that's smaller than or equal to 2? No, there's not. How about 23? Okay, there is one smaller than 23. It would be 18. That's the second multiple of 9. And when I subtract, I get 5. Bring down my 5. 55, the number that's smaller or equal to 55 is 54, which is 26 times, 6 times 9. And that's 54. We subtract, and we get a remainder of 1. There is another way to deal with remainders, and that would be to go into decimals. On normal problems, just problems that I want you to do, there's not much of a need. Not much of a need to go into decimals. I would really just look at here. I want to get to an answer as quick as I can. I'm not really doing much with it, so I'm going to put that remainder of 1 over 9. Now, if I was doing something else with the answer to that problem, or if it was like a money problem or something like that, then decimals might make sense, right? So this one is just a problem that it gives me, and I'm not really looking for anything past that. And so we get 26 and 1/9. The next problem is where we might use something like this. So I want to make 30 equal payments for a go-kart. The go-kart costs a total of $1,380. How much will each payment be? That problem turns into a $1,380 divided by 30. I need a list of multiples of 30. We get 30, 60, 90, 120, 150, 180, 210, 240, and 270. And I'm starting the process the same way. Is there a number on my list smaller than 1? No. 13? No. 138? Yes. Okay, so I needed to move 3 digits over before I got my first one that was smaller, and that would be 120. And I'm subtracting those. I don't want anybody to think that we're doing a division problem and a division problem there, so let me get rid of that. 120 is the 1, 2, 3, 4th multiple of 30. And when I subtract, I get 18. Bring down my 0. And looking for a number smaller than or equal to 180. 180 is on my list. It is the 6th multiple of 30. And when I subtract, I get 0. So it looks like if I want to buy this go-kart for that much money over 30 months, I'll be paying $46 per payment. Now, obviously, that's smaller than what we ultimately have to pay. It will add up to $1,380, but it's maybe a more manageable payment. Obviously, sometimes this happens in the real world, and there's another aspect that I'm not really addressing, and that would be an interest rate. Okay? Trying to avoid that if we can. So the last one that we're looking at, we want to see if we can pay that go-kart off sooner and pay it in 16 equal payments. So the cost is the same, 1,380, and I just want to pay it off in 16 payments instead of 30. So I need some multiples of 16. We have 32, 48, plus 16 will be 64. Uh-oh. 48, 64, 80, 96, 112, I want to say 28, yeah, and last one would be 144. Trying to add 16 every time and do that quickly. So let's go ahead and get started here. The process starts the same. There aren't any numbers on my list that are smaller than 1 or 13, or and not until I get to 138. And the number that's the biggest one, that's still smaller than 138, is 128. Okay, 128 is the 8th multiple of 16. And when I subtract, I get 10. Bring down my 0. And I'm looking for a number smaller than 100. That's 96. 96 is the 6th multiple of 16. And when I subtract, I still have a remainder. I have a remainder of 4. And in a problem like this, it probably makes sense to talk about decimals because we're dealing with money. So when I'm dealing with a decimal remainder, I'm going to put a decimal in my dividend and a decimal in my quotient. And I'm going to add another 0. Bring that down. Looking for a number smaller than 40. That would be 32. That's the 2nd multiple. And when I subtract those, I get 8. I'll need another 0 because I still have a remainder. And I'm looking for 80. 80 is on my list. I'm going to kind of do this weird a little bit just because I'm kind of running out of room right there. 80 is the 5th number on the list, and that gives me no remainder. So it looks like I will pay, if I want to pay 16 equal payments, I'll be paying $86.25 per payment. Okay, we will do a little bit more practice with long division and some of the steps involved over the next week or so. Well, probably quite a while, but specifically with whole numbers and even whole numbers resulting in decimals like this one, we'll get some more practice at that as we go. So hopefully that helps make some sense of things. Have a great day, and we'll see you in class.